Welcome back. So now we start on problems on section 6.1, Stat 6.1, Statistics 6.1. Problem 1. Determine whether the following examples are discrete or continuous data sets. Write discrete in capital case for discrete and continuous capital case for continuous without quotations. So remember, discrete and continuous. One way to distinguish between the two, do you ask how many or how much? How many would represent discrete, that is countable, and how much is continuous. So how much is continuous, that is uncountable. The number of errors found on a student's research paper. Do we say how much errors or how many errors? We say how many errors. So it is discrete. Remember, they want us to use capital case. Make sure you spell correctly. Yeah. The length of time needed for a student to complete a homework assignment. Do we say how many time or how much time? We say how much time. So that's a continuous. The number of customers waiting in line. Do we say how many customers or do we say how much customers? How many customers. So that's discrete. The number of voters who vote Democratic. How many voters or how much voters? We say how many voters. So that's a discrete. Next problem. Determine whether the following are valid probability models or not. If it is valid, type valid in capital case. If it is invalid, then say invalid in capital case. Okay. One thing for probabilities is that your probability should be greater equals 0, which it is. Every probability should be greater equals 0, and every probability should be less equals 1, which it is. Yeah, every probability is less equals 1. So that's condition 1, greater equals 0, less equals 1. Second condition, they should all add up to 1. So let's see, do they add up to 1? Let me use a calculator. There. So 0.2 plus 0.1 plus 0.5 plus 0.2. It does equal 1. So this is valid. All right, it is valid. Here, E1, E2, E3, E4. Is everything greater equals 1? Fine, fine, not fine. Greater equals 0, I'm sorry. So you need to be greater equals 0, less equals 1. So that is not greater equals 0. That is not less equals 1. Okay. So regardless, it is invalid. Next problem. Okay. Given the discrete probability, 9, 10, 11, 12, 13, you have these probabilities. Determine the following. Probability x equals 9. 9 is here. Its probability is 0.2. Probability x greater than 10. Greater than 10 means about 10. 11, 12, 13. So it could be this or this or this. That's what it means. So when you say or, you end up adding these numbers. Greater equals 10 means probability 11, which is 0.2, plus probability 12, which is 0.1, probability 13, which is 0.4. I took these three numbers and added them. This one says 9 probability of 9 less equals x less than 11. That means x equals 9 is okay. You are accepting the possibility that x be 9. On the other hand, x has to be less than 11. So x cannot be 11. So the only options here for x are 9 and 10. So I'm going to add these two numbers. 0.2 plus 0.1. 0.2 plus 0.1 because x is allowed to be any one of these. Next problem.